The second part of this question we are solving is to identify the number of sigma and pi bonds in this structure. Sigma bond, pi bond. Now listen, I hope you know that anywhere you see a covalent bond, that covalent bond is either a pi bond or a sigma bond. How does a pi bond differ from sigma bond? I'm sure you have known that in our Chem 101. Pi bond is a weak covalent bond. Sigma bond is stronger than pi bond. So whereas pi bond is weak, sigma bond is strong. During chemical reaction, pi bond is broken before the sigma bond. Since pi bond is a weak covalent bond, in a chemical reaction, it is broken first before the sigma bond. Another thing you need to know about pi bond is that it is mobile. Pi bond is delocalized. It can move from one place to another. It is mobile. It is delocalized. Okay? But sigma bond is localized. Another thing is in terms of their mode of formation. One way we form sigma bond is by the overlap of hybrid orbitals. When two hybrid orbitals overlap, we did hybridization in first semester. When two hybrid orbitals overlap, okay, linearly, you're producing sigma bond. But for pi bond, we form pi bond. One way we form pi bond is by the lateral, that is parallel overlap of two unaffected p orbitals during the process of hybridization. In hybridization, we are mixing atomic orbitals of different energies and shapes to produce identical ones so that a chemical reaction can take place. Okay? What we do in hybridization is to mix atomic orbitals of different energies and shapes to produce identical ones so that a chemical reaction can do what? Take place. Alright. Now, in the course of mixing these atomic orbitals of different energies and shapes, the p orbitals that are not mixed, the p orbitals that are not blended, the p orbitals that are left unaffected in the hybridization process, they can overlap in a parallel manner, just like you have this p orbital. This is p orbital. If I have another p orbital, can you see? This is a parallel overlap. This overlap is going to produce a type of bond we call pi bond. Okay? And then, of course, another thing you must have in your mind going into this exam hall, Chem 102, Organic Chemo, is that in the formation of pi bond, the bonding electrons are far from each other. The language we use here is that the bonding electrons are far from the imaginary line that joins the two nuclei. The bonding electrons are far from the imaginary line that joins the two nuclei involved in the overlap. And that explains why pi bond is weak, why a sigma bond is what? Strong. Is that okay? So, but that's by the way. How do you identify a pi bond in organic structure? It's very simple. It is only where you have multiple bonds, either double or triple, that you see a pi bond. Every single covalent bond is a sigma bond. Know that and have inner peace. Every single covalent bond is a sigma bond. We only see pi bond where there is double bond or triple bond. Is that okay? If you have a double bond like this, one of them is sigma, one is pi. If you have triple bonds like this, only one of them is sigma, the other two are pi bonds. That you must know. So we only see pi bond where there is a multiple bond. So if the question is asking me to identify how many sigma bonds, how many pi bonds we have in this structure, all I need to do is to expand this structure, expand it in a way that I can see how the atoms are linked together. Are you with me? So I can know those who are double and those who are single bonds. So I can redraw this. Let us do this together. Follow me. First of all, remember that we have 5 carbon atoms. So I will do 1, 2, 3, 4. The 5th carbon atom is the one that has OCOOH. Now, this is a carbonyl group. Please, in organic structure, anywhere you see oxygen, it must be surrounded by 2 bonds. Anywhere you see oxygen, that oxygen atom must be surrounded by 2 bonds. The reason is that oxygen has a bond order of 2. The bond order of oxygen is 2. Is that okay? So I cannot write CO like this. I will connect oxygen with 1 bond. No, it's not allowed. Bond order of oxygen is 2. So there must be 2 bonds connecting it. So the next thing I will have is OH. Remember, it is COOH. Now, again, to confirm that this oxygen atom in OH, there are 2 bonds that surround it. 1 bond connects it to carbon, another bond connects it to hydrogen, confirming that it must be surrounded by 2 bonds because it has a bond order of 2. Is that okay? So, 1, 2, 3, we have double bond here. And then remember, we have hydroxy group here, OH group. You see the way I drew it out, so I can clearly see the bond. Oxygen here is surrounded by 2 bonds. This oxygen is bonded to carbon and then also bonded to hydrogen. All right. So here we have hydrogen. We have hydrogen. Hydrogen is here. Hydrogen is here. You have hydrogen here. Hydrogen here. Now remember that carbon is tetravalent. That means for any organic structure to be correct, each carbon atom must be surrounded by a total of 4 bonds. My people, it is valency of 4 that carbon uses to form a stable compound. Carbon is tetravalent. So for organic structure to be correct, make sure that each carbon atom is surrounded by a total of 4 bonds. It shouldn't exceed 4. This is 1, 2, 3, 4. If I put another hydrogen now, it will make it 5. Not allowed. 1, 2, 3, 4. So I don't need to put extra hydrogen here because each of the carbon atoms here is already surrounded by a total of 4 bonds. All right, so let's visit all the bonds. Every single bond is sigma. The only place you see pi bond is where you have multiple bond, which is either double or triple. So this is a single bond. So it's sigma, 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 sigma bond, sigma bond, sigma bond, sigma bond, sigma bond. Now, I have attended to all the single bonds, which are sigma bonds. Now, this is a double bond. One of them is sigma, one is pi. Here I have double bond. One of them is sigma, one is pi. So let us count the total number of sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here we have 15 sigma bonds. 15 sigma bonds. How many pi bonds do we have? Just 2 pi bonds. That's what we have in this structure. Remember, the structure is 1, 2, 3, 4, 5. 5. That means 5 hydroxy. 5 hydroxy. The hydroxy group is seen or bonded to carbon number 5. We count from where the main functional group is, which is carboxy group. 1, 2, 3, 4, 5. 5 hydroxy. Remember, a number has to be separated from a name using hyphen. Take note of that. And this name here must start with capital letters, not a style. Okay, so we have 1, 2, 3, 4, 5. That's why I say 5 hydroxy. 1, 2, 3, 4, 5. So you say pent. 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 There's a double bond at position 3. 1, 2, 3. So you say pent 3 enoic acid because of COOH. Enoic acid. So that is the man involved. 5 hydroxy, pent 3 enoic acid. In this compound, we have 15 sigma bonds and 2 pi bonds. Did you understand?